Hey guys, in this lesson, we're going to be talking about quadratic functions. What is a quadratic function? Well, first of all, it could be a polynomial. Well, what is a polynomial? Or it could be a trinomial. What's a trinomial? Trinomial is an algebraic expression that has three different algebraic expressions or variables, just like the example we see here with negative x squared plus 4x plus 3. So we could say ax squared plus bx plus c is considered a quadratic function. A quadratic function is a function that has a degree of 2 for x. This has a degree of 1, but at the most it has a degree of 2. So we can say that this trinomial is considered a trinomial because it has 1, 2, 3 different algebraic functions, but it is also a quadratic function because its highest degree is 2. So when we're looking at our first problem, we're going to graph the quadratic function negative x squared plus 4x plus 3. And the way you graph is we will say this is y equals. So we'll come off to the side and we'll complete our xy coordinates. Let's just say negative 1, 1, 2, 3, 4, 5. We'll go from x being negative 1 to 5 and find out what y is. That will allow us to graph our quadratic function. So I hope that helps. So let's get started. First up, we're going to say x is negative 1. So we'll start with a negative. We'll have a negative 1 here, squared, plus 4 times negative 1, plus 3. So when we're doing our algebraic functions, we got to make sure that we're doing our order of operations in the correct order. So the first thing that we're going to want to do is make sure that we do exponents first. So negative 1 squared is negative 1 times negative 1, which gives it a positive 1. But we still have this negative here. So that would be negative 1. 4 times the negative 1 is negative 4. And then we have plus 3. So when we combine like terms, we have negative 1 minus 4. That gives us a negative 5 plus 3, which gives us a negative 2. So if x is negative 1, then y is negative 2. Moving on to the next coordinate, we plug in 0. So we have 0 squared plus 4, 0 plus 3. 0 squared is just 0 times 0, which is 0. Negative 0 is still 0. 4 times 0 is 0. So we're left with 3. So when x is 0, y is 3. Okay, next problem. If we plug in 1 before we plugged in negative 1. So now it's just 1 plus 3. So 1 squared is 1 times 1, which is 1, but we still have a negative here, so that's a negative 1. 4 times 1 is 4, so plus 4, and then plus 3. So we have 4 minus 1, which is a 3, plus another 3, which gives us 6 whenever x is 1. All right, the next problem is we're going to substitute 2. So we have negative 2 squared plus 4 times 2 plus 3. 2 squared is 4. We put the negative here. 4 times 2 is 8. And then plus 3. So we essentially have 8 minus 4, which is 4 plus 3, which gives us 7. Okay, for the next number, we're going to use 3. And so we have negative 3 squared plus 4 times 3 plus 3. 3 squared is 9. with the negative in front, that's negative 9 plus 12. 4 times 3 is 12 plus 3. So we have 12 minus 9, which is 3, and then 3 plus 3 is 6. All right. Next, we're going to substitute x with 4. So we have negative 4 in parentheses squared plus 4 times 4 plus 3. So 4 squared is 16 with the negative in front. 4 times 4 is 16, so plus 16 plus 3. Those cancel, so we're left with 3. And then lastly, we're going to substitute x with 5. We have negative 5 squared plus 4 times 5 plus 3. 5 times 5 is 25, so that's a negative 25 plus 4 times 5, which is 20 plus 3. So basically we have minus 25 plus 20, that's a negative 5 plus 3, which gives us a negative 2. So you may be wondering, if I were to plug in a number here, why isn't it the negative first? But we remember, when we're looking at order of operations, we could use the acronym PEMDAS, which would be in parentheses, exponents, multiplication, division, addition, subtraction. So technically, here is a negative 1 times. So you would do you would use the exponents first and then multiply by the negative 1. So hopefully that helps. Hopefully that makes sense. So now we can get ready to graph our coordinates to see what a quadratic function looks like. Okay, we're getting ready to graph our quadratic function. I have some lines here. Let's see if I can make a straight line. When we get ready to graph, this is our y-axis and this is our x-axis. So it looks like our highest number is 7 on the y side and then 5 on the x side. So 4, so we can go 1, 2, 3, 4, 5. We'll have negative 1, negative 2, say negative 3, negative 5. Okay, and then for y, we have some negative numbers. So we could go negative 1, negative 2. You have 1, 2, 3, 4, 5, 6, and then 7. So now let's look at our coordinates. Our first coordinate is 0 for x and 3 for y. So we're going to go 0 here for x, because this is 0, and then 3 for y. So this is our first coordinate, which is 0, 3. Actually, that was our second coordinate. So let's go to the first one, which is negative 1, negative 2. So we have negative 1 for x down to negative 2. So negative 1, negative 2. Next, we have 1 and 6. So we have 1 all the way up to 6. So 1, 6 is right here. Then we have 2 and 7. So this is we're going from 2x to 7y. So we'll say that's 2 and 7. So we have that. Then we have 3 and 6 coming back down. So this is 3. and 6. Next we have 4 and 3. So that's 4 and 3. And then lastly we have 5 and negative 2. 5, negative 2. So we went across 5 for x, down 2 for y. So now let's go ahead and graph this. And what we're doing is we're going to connect all points. So let me do that. So we're just connecting all of our points here. And then we want to connect our points here. So this is what a quadratic function looks like. This is what you would call a parabola. P-A-R-A-B-O-L-A. And it looks like this parabola is pointing down. So if someone were to ask you what is the domain and range of this quadratic function, basically the domain is what is the x range, and then the range is what is the y range. So when we say range, if we look at x, this goes from -1 to 5, but we could keep going, so these numbers may change. So the domain for x, you could say, is, I'll just say real numbers. And then for y, the highest point is 7, and then y could go on forever as you're going down. So we could say y, the range for y is less than or equal to 7 for the y range. So that is how you graph a quadratic function. We'll continue on in the next video to graph more quadratic functions. This is a quadratic function that's pointing down. The way this looks is what you call a parabola. We have our xy coordinates, which is what we plug into our equation, our quadratic function, which is also a trinomial because it has 3 different variables. But the reason why it's called a quadratic function is because its highest degree is 2. So I hope this helps. I hope this helps you and anyone else. If it does help you, send it to someone else. And we'll see you in the next video to do more quadratic functions.